Now this part of compound interest and simple interest is called as growth and depreciation. Now, what do you mean by growth? So, growth is simple to increase the rate of something, okay, to increase when there is anything increment, when there is an increment in something, you called it as a growth. For example, you learned about compound interest and simple interest. In that, your money was growing year by year, it was growing. So, it is called as growth. But now, growth is not just only in money, everything. Your height when you were small, okay, as the years passed on, your height got increased, your weight got increased, okay, everything got increased. Number of bacteria got increased, number of population in the world got increased, okay. So everything is increasing, means there is a growth in each and everything. Now, what is the rate of growth? Means if something is growing, now what is, how much, in what speed it is growing? So the speed that tell us the growth in the amount of time is called as rate of growth. For example, your height is increasing this much by this much percent in every year. So that will be your rate. Okay. Simple. In compound interest, we used to find the rate of interest. There is the same thing which is called as rate. Now, let us take a best example of population. Sorry. So in population, okay, if we talk about population, we have a three simple formulas to find the population in the growth section. Okay. Uh, I remember one more example of growth. For example, if you buy a gold, if you buy a car, okay, I give you the same example. I have a gold and a car. Okay. Now, if you buy a gold, the rate of gold goes on increasing year by year by year. So this is called as growth. And now, if you buy a car, okay, let us take an example that you have bought gold 10 years back. So now the gold that you have is 10 years old. So before 10 years, you must have bought it at some amount, but now if you sell it, the amount has been changed, the amount has been increased. So this is growth. Now the same thing happened. He has bought a car 10 years ago. Now, after 10 years, if he is going to sell the same car, is he going to get the same amount in which he bought the car? No. Okay. Here, the rate got the value of that car got depreciated. Okay. Means it has gone down because now he has used that car. You cannot say there is growth in each and every item, and you cannot say there is depreciation on each and every item. Okay, so we are studying about the growth, and we have taken an example of population growth, and we have formulated the three formulas over here. So if you have to find the population after n number of years, we don't know, that will be given in the question, n numbers of years, 2 years, 3 years, 4 years. So the population, we have to find it over here. So the formula goes as present population multiplied by 1 plus r upon 100 raised to n. I think so. This is a familiar formula you have already learned in compound interest. Now this formula is for finding the population after n number of years. Okay. For example, the present population is 5. Okay. Calculate the population after 10 years. So you will this formula. Next, present population. If you have to find the present, what is the actual present formula now? Present population now. So it will be population n years ago before multiplied by this formula, which is 1 plus r upon 100 raised to n. Here r means the rate of increment. At what rate it is being growing, and n is the number of years. Correct. So this is the two formula that we have learned now. Population after n years and the present population formula. Now third, If the rates of growth are different for different years, you have to find the population after 3 years. But each and every year, okay, the rate of growth of population is different. First year it was 5%, second year it is 7%, okay, third year it is 10%. So 3 years, three different rates. So this is the formula that you will be using over here, multiplied by the present population. Understood these three formulas? Okay. Now we'll take an example related to all these three formulas. Okay. Now, the question says that the population of town increases by 10% every year. If the present population is 60,500, find the population after 2 years and 2 years ago. Means after 2 years and what was the population before 2 years. Okay. So first we'll write what is given over here. So solution. Okay. Rate we have given. Rate is equals to 10% and present population. Present population is 60,500. Now first thing we have to find out population after 2 years. The formula is population after n years, n is over here 2, after 2 years is equals to present population into 1 plus r upon 100 raised to n. So present population is 60,500 into 1 plus what is r, 10 upon 100 raised to 2 in this case. Now we'll solve this. So 0 0 get cancelled, 6 0 5 double 0 multiply by 10 ones are 10 plus 1, 11 upon 10 multiplied by 7 upon 10. 0 0 get cancelled, 0 and 0 get cancelled. So 605 into 11 into 11 is 121. So if you calculate this, which is 73,205. So the population after 2 years will be 73,205. Okay. Now the next part. Next part is population 2 years ago. So the formula is present population is equals to population n years ago 1 plus 100 raised to n. You know present population is 60,500. Population after n years we don't know. Let us take it as x into 1 plus 10 upon 100. We have to find number of years is 2. Okay. Solve this. 60,500 is equals to x. 0 0 get cancelled, 10 ones are 10, 10 plus 1 11. 2 times, so 11 upon 10 into on 10. Take the whole term 11 upon 10 into 11 upon 10 on this side. So this will give you x is equals to 60,500 into 10 upon 11 into 10 upon 11. As you move this side, this whole part over there, it get reciprocal. Now Thus 11 into this goes 11 is 605 upon 11. 11 ones are 11, 11 5s are 55, and 5, okay, 11 5s are 55, 0 0. Again 11 ones are 11, 11 5s are 55, 0 0. So x is equals to 500 into 10 into 10. Therefore x value is 50000. So population 2 years ago was 50,000. Understood how to use this formula, how to solve the problem? Yes? Okay.